In 2.3, we're going to look at the product rule. So in 2.2, we looked at the sum of the difference rules, and we're able to, if we have two equations that are added together, we're able to take the derivative of both equations separately and then add those, and it works. We also do the same thing with the subtraction. In regards to the product of two derivatives, it does not work. And we're going to take a look at that right here and kind of just prove it. Example 1, let p at x equals f at x times g at x. Okay, so that's multiplication, where f at x equals x squared plus 1, g at x equals x plus 5. So we're going to show that p prime at x does not equal f prime at x, g prime at x. Okay, so first, f prime at x, let's actually just take the derivative of this. So it's 2x, because it's 2x plus 0. And let's multiply it by the derivative of x plus 5, which is just 1. Okay, so we're trying to prove that p prime at x does not equal 2x. Okay, p prime at x, what I'm going to do just over here on the side is I'm going to actually just simply expand these brackets. I get x cubed plus 5x squared plus x plus 5. Now, we get 3x squared plus 10x plus 1. Okay, it is easy to see that 3x squared plus 10x plus 1 does not equal 2x. Okay, so just to recap, we cannot take both the derivative of f at x, the derivative of g of x, and then just multiply them. It does not work like that. Okay, instead, this is how it works. What we do is we take the derivative of the first term, write the second term as it is, then add this first term as it is, derivative of the second term. Here's the proof for that. I'm going to use the definition of the derivative. So p prime at x equals the limit as h approaches 0. Okay, using the definition of derivative, we have f x plus h, g x plus h, minus f at x, g at x, all over h. In order to evaluate this, I'm going to add in technically 0, but how it's going to look is I'm going to add into the middle f at x times g x plus h. Okay, and then I'm going to subtract it out. So technically, I'm just making a little this equation look a little bit different, but it's actually the same equation because I just added in 0. Okay, so I'm going to put this all over h. Now, I'm just going to regroup, okay? So the limit as h approaches 0, I'm going to put different things together here. I'm going to factor out, I'll do a different color. I'm going to factor out this g, x plus h, from the first two terms. Okay, let's see what we get. So factor out the g, x plus h. We are left with f at x plus h plus I'm going to actually take the minus one. Minus f at x all over h. And this right here should look familiar now. Okay, and out of, so we've used this term right here. And sorry, we haven't used this term. We use the minus because my goal was to get the subtraction here. So this looks like the derivative of f at x. Because now if we write this, we know that the limit as h approaches 0 of this is just f prime at x. And from the two remaining terms, let's do these in another color. Okay, out of this term and this term, what can we factor out? Well, we can factor out just the f at x. Okay, so plus the limit as h approaches 0, factor out f at x. We're left in this bracket with g of x plus h minus g at x all over h. And if you take a look at this bracket should look familiar as well. So now looking at all of these individually, we have the limit as of g, x plus h, and then the derivative of x prime of h. And then let's add the f at x, and then the derivative of g at x. Pretty much is what we're getting here. So we can just rewrite that as the limit of f times g at x plus f at x times g at x, g prime at x. A short form way of writing this is u prime v plus uv prime. Now let's get into some actual examples. Okay, let's differentiate this. So we have the first term here. This is going to be our f at x, and this is going to be our g at x. Okay, I'm actually going to cheat. I'm going to do the uv. So u prime v plus uv prime. And this is going to be h prime at x. Okay, so h prime at x equals, what is the derivative of the first thing? We get 2x minus 3 times the second thing as it is, plus first thing as it is, times the derivative of the second thing. Okay, now we can choose to expand and simplify. I'm okay leaving it like this for now. I'll expand and simplify maybe these easy ones, but not when it gets to the harder ones. So I get 2x to the 6 plus 4x minus 3x to the 5 minus 6 plus 5x to the 6 minus 15x to the 5. Like terms are here and here, here, and here. We have 7x to the 6, negative 3 minus 15, negative 18x to the 5, plus 4x minus 6. And that's the derivative of this f at x, g at x.